two packing crates of masses 10 kg and 5 kg are connected by a light string that passes over a frictionless pulley as in the figure. The 5 kg crate lies on a smooth incline of angle 40 degrees. Find A, the acceleration of the 5 kg crate, and B, the tension in the string. Okay, so we have this 10 kg crate, and obviously it is heavier than 5 kg. So intuitively, this will move downward, right? Because it is heavier than that 5 kg. So this one will be our movement direction. Okay. And then if this 10 kg moves downward, this 5 kg moves upward, right, to the plane. And then we need to do free body diagram at the 10 kg crates and also on the 5 kg crates. Let's draw the free body diagram at this 10 kg crate first. So obviously we have its weight, right, pulling it down. So I will have FW1 here. And then on the opposite side, we have the rope here pulling it up with the tension, right? So we will have the tension here, T. But then this tension also pulling this crate up, right? The same tension. Remember that it is the same rope. So we will have this one here in this direction as T. And what else that we have from here? We also have the weight of the crate, right? So we will have FW2. However, we need to decompose it into X and Y component, right? So here we will have FW2 on the X direction, FW2 on the X direction, and then here we will have FW2 but on the Y direction. But then we have this angle here is 40 degrees, right? This angle here is also 40 degrees because the incline here is 40 degrees. So this angle is 40 degrees. This angle here between y-axis and the force here, the weight. So we can write out this FW2 on the X direction. What is it? Because this one here is in the hypotenuse here, FW2, Y is the adjacent side, right? Because the angle is here. But then FW2 is on the opposite of the angle, right? So here, maybe let's think as both forces here. So here the adjacent and hypotenuse is the cosine. So I will have cosine of 40 degrees. So we'll have FW2 here. And here, obviously, because that is cosine, we also have this one as sine 40 degrees. Good. And I think we can do Newton's second law analysis on this crate and also this crate. Okay, let's start with at 10 kilogram crates. We can have the Newton's second law, right? So we will have sigma F is equal to the mass times acceleration. Okay, what force that works here? We have the weight of this one, right? So I have FW1. But then we also have this rope here pulling it up with its tension. So I have minus T. And remember, this one is positive because the movement direction is here, right? So we will have the mass times acceleration here. But the weight of this one is mass of crates 1 times gravity and then minus T, and that will equal to the mass times acceleration. Okay, now we can plug in the numerical values. We will have 10 multiplied by 9.8 and then minus the tension here, and that will equal to the mass, which is 10 times the acceleration. Or we can isolate this, so we will have T plus 10A, and that will equal to 9.8 multiplied by 10. That will be 98. Okay, let's have this as equation number 1. Okay, and now let's move on to add 5 kilogram crate. We can also have the Newton second law. Sigma F is equal to the mass times acceleration. Okay, remember that this crate moves upward, so the positive one is here. We will have T and then minus Fw2, x. Fw2, x, and then that will equal to the mass of crate number 2 times the acceleration here. Okay, but then Fw2x is this one here, so I will have T minus Fw2 sine of 40 degrees, and that will equal to mass number 2 times alpha. But the weight of crate number 2 is mass number 2 multiplied by G, and then sine of 40 degrees, and that will equal to mass number 2 times acceleration. Okay, now let's plug in the numerical values. So I'll have T minus 5 multiplied by 9.8, and then multiplied by sine of 40 degrees, and that will equal to 5A. Good. Now we can isolate this to the left hand side, so I'll have T minus 5A, and that will equal to 5 multiplied by 9.8 sine of 40 degrees. Okay, and then we'll have T minus 5A. Okay, let's get the numerical values of that number. Let's use our calculator. So we will have 5 multiplied by 9.8 sine of 40. Okay, I will have 31.49. No, 31.50. 31.50, and this is equation number 2. Okay, so now we have 2 equations and 2 variables. We can solve them, right, using calculator. Okay, let's solve it as equation solver here, which is number 5, and we will have 2 variables, number 1, and let's plug in the coefficient. We'll have 1 and then 10 and then 98. And the second one, I will have 1 minus 5 and then 31.5. Okay, so we will have our T here, right? The X values is T, and that T is 53.67. And the unit here will be in Newton. And then what is the acceleration? We will have this one here, 4.43. 4.43. And the unit here will be meter over squared seconds. And this is the answer for question A, and the tension is question B. Okay, I think that's all for this problem. Thank you for watching. See you in the next video. Bye bye.